This question is from Chapter 8, Section 1 on the distribution of the sample mean. Okay, so the first part of this problem, we're talking about a game of roulette that has 38 slots, and you spin a metal ball around the roulette wheel, and it falls into one of the slots. And if it matches the number you chose, you win $35. Otherwise, you lose $1. The first thing that you're asked to do is to construct a probability distribution of the random variable. So you have to go back and think about what this is asking. So this, you have basically discrete chances of winning or losing. And this is actually from section 6.1 in the book for discrete random variables. So to calculate the probability distribution for the random variable, you have to think about your chances of winning $35 versus losing $1. So you have 37 opportunities to lose $1 and only 1 opportunity to win 35. So your random variable is the amount of money that you win or lose. And so you're trying to calculate what that probability is of winning $35 in a single spin. Well, that's at 1 chance out of 38. So you just go into a calculator and you take 1 and you divide it by 38 and you get 0.0263. And since the probabilities have to add up to 1, you subtract that number from 1 to get the 0.9737. So this is your probability distribution. What you're going to do to get to the next part, which asks for the mean and the standard deviation, is this is actually incorrect on the screen here. I think you're going to go in and use StatCrunch. So you open up StatCrunch, which I have opened already, and you're going to actually type in your probability distribution. So this is your random variable x, and this is your p of x. And so we're going to do 35 and -1 and 0.0263 and 0.9737. So this is our probability distribution for our discrete random variable x. And we're going to calculate the mean and the standard deviation for this. So we're going to go to Stat, Calculators, Custom, and our values are in x, our weights, that's our probability, and then we're going to just hit Compute. And compute. Okay, so this is our mean, -0.0532, and this is the standard deviation. So that's what gets entered into part B.